Our question today is, suppose that the grade point averages of undergraduate students at one university have a bell-shaped distribution with a mean of something, they don't give it to us, and a standard deviation of something else. So unfortunately, this problem is missing two key pieces of information. So we're not going to be able to answer this question specifically, but I can show you how you would answer it once you know what that mean and standard deviation are. The question is, using the empirical rule, what percentage of the students have a grade point average, have grade point averages that are at least, and they don't give it to us here, but up here they tell us at least 3.72. Please do not round your answer. Using the empirical rule, you're generally not going to be rounding answers because the empirical rule is not precise anyway. We're talking about things that are about this. They're not, we don't have actual numbers or very precise numbers. We have general numbers. So let's talk first about what is the empirical rule. A bell-shaped distribution means that we're talking about a normal distribution. So whenever we have normal distributions, they look like this, approximately. And our mean is right in the middle. And we can look at 1, 2, and 3 standard deviations above the mean. This is plus 3. That is a 3. And 1, 2, 3 minus 3 standard deviations below the mean. So these tick marks are 1, 2, and 3, minus 1, minus 2, and minus 3. So the empirical rule states that if this is a distribution of all undergraduate grade point averages at this university, 68%, about 68%, it's not exactly, but about 68% of all of those grade point averages are going to be between -1 and 1 standard deviation of the mean. In other words, they're going to be within 1 standard deviation of the mean. If I go to 2 standard deviations, that percentage is going to be 95%. So about, not exactly, but about 95% of all the grade point averages at this university are within 2 standard deviations of whatever the mean grade point average is. And finally, about 99.7%, so almost everything, is within 3 standard deviations of that mean. So let's assume that we have a mean of 2.72 and a standard deviation of 0.5. Then our grade point average of 3.72 is it's going to have a z-score, and a z-score is just tells you how many standard deviations you are above or below the mean. So the z-score for 3.72 is the data value minus the mean divided by the standard deviation. So you can see that tells you how many standard deviations you are away from the mean. And so that's going to be 3.72 minus 2.72 divided by 0.5, and that's equal to 2. So if our mean was 2.72 and our standard deviation was 0.5, then our grade point average of 3.72 is 2 standard deviations above the mean. So it would be right here, 3.72. And we want to know the percentage of students that have grade point averages that are at least 3.72. That means 3.72 or more. So we're interested in this area under the curve. The area under a normal curve, it's called a density curve, tells us the proportion of the distribution that is in that area. So we want the area above 3.72. Well, we know that this area between +2 and -2 standard deviations, that area that I've kind of shaded in green, that was 95% of the area under this entire curve. The area under the whole curve is 100%. So the area in those two tails, we're looking at the upper tail. The lower tail is this part. So the area in these two tails outside of our 95% is going to be 1 minus 90 or 100 minus 95, which is 5. So the area in both tails is 5%. We're just looking at one of the tails, that's half of that. So half of 5% is 2.5%. So the answer to this question is 2.5%, about 2.5% of all the undergraduate students at this university have grade point averages of at least 3.72. Now, the exact answer to this specific question is going to be different because it probably has a different mean and standard deviation. But since they wanted you to use the empirical rule, that the 3.72 needed to have been either 1, 2, or 3 standard deviations above the mean, more than likely above the mean, because 3.72 is a fairly high grade point average. I hope this helped. If you have any other questions, please don't hesitate to contact me and I will try to answer them for you.